Mystery of the Skynet satellite. Back in the late 1960s, a satellite was built by the Philco Ford Company, and it was named Skynet 1A. This was a communications satellite designed for the purpose of relaying communications for British military forces. It was launched into a geostationary orbit by a U.S. Air Force Delta rocket in 1969 and positioned above the east coast of Africa. After launch and testing was completed, control of the Skynet 1A was then handed over to the British RAF. The satellite was functional until 1977, when the RAF handed control back over to the U.S. The satellite was originally positioned at 40 degrees east longitude. It is now at 105 degrees west longitude at an altitude of 22,369 miles, and nobody knows how it got to this location. The control and command logs do not contain any explanation of how this satellite moved halfway around the planet. It is now in a gravity well, which brings it close to operational satellites in geosynchronous orbit above the American continent. If it had died at 40 degrees east, it should have drifted to a gravity well at 75 degrees east, which is above the Indian Ocean. A gravity well is a location where an uncontrolled satellite wanders around like a ball bearing in the bottom of a beer bottle. A satellite in geostationary orbit must be directly above the equator, with a velocity of 1.91 miles per second and an altitude of 22,236 miles. This orbital position keeps the satellite in the same place above Earth as the planet rotates, thereby making it possible to send and receive signals with a fixed antenna on Earth. We have all seen video of the astronauts aboard the International Space Station floating weightless in low Earth orbit, but gravity is still in effect, even at the distance of 20,000 miles or more. This is what prevents satellites from flying out into space away from their Earth orbits. The position of a satellite does not remain fixed by magic. Forces exerted by gravity of the moon and sun will over time move the satellite from its desired position. Satellites must be constantly monitored and thrusters are activated to correct for external forces. As a satellite reaches its end of life, it is placed in a graveyard orbit farther away from Earth. If a satellite is impacted by space junk, wanders from its intended orbital position, or explodes, it is a threat to other assets in space. October 19, 2024. A Boeing Space Systems communications satellite, IS-33E, exploded into 57 pieces of space junk. This 14,600-pound payload was placed in orbit August 2016. It experienced several issues with the onboard propulsion systems during its short lifetime. It was designed to be operational for 15 years. This is the Epic NG-702MP satellite model built by Boeing. 2 of these have failed due to sudden loss of power and subsequent explosive breakup. The first failure occurred in 2019, and now the IS-33E in 2024. Speculation regarding the cause of these failures includes solar activity, micrometeorite impact, and various theories. One component they had in common: lithium-ion battery power supplies, and sudden loss of power prior to the explosive destruction of both satellites. Every design engineer should be aware of the hazards posed by lithium-ion battery designs, yet they continue to specify these power supplies for use in a wide array of products, including very expensive space-based assets. The fragments of space junk resulting from the explosion of this one satellite is estimated to be 57, but these are only the large pieces that can be detected by ground-based tracking. The actual number of fragments is likely to be in the hundreds or thousands. This space junk is a threat to other assets in geostationary orbit, and someday it will become a problem for some other satellite that we depend on. Thanks for listening to the podcast.